Yeah. Good morning, guys. Welcome to the lecture 34 of UNIT3 in Environmental Engineering subject. So, in the last class, in the lecture 33, we have discussed about the sedimentation. What is the meaning of sedimentation? Why we are doing sedimentation in the primary treatment plant of wastewater. So, we have discussed the sedimentation process and also the other primary treatment process. So in this class, we'll discuss about the sedimentation types. In this class, we'll discuss about the sedimentation types, and also the composition of wastewater. Okay. Yes. So I'll make to allow to join the class. Okay. So we are at this stage, sedimentation, and also the design of preliminary and primary treatment units. So as usual, this is a house where you are seeing all types of things where you already studied in the first and second units. So here the place where we are. So we are at this position where the water is getting treated, which is coming from domestic usage, which is coming from storm usage, and also from the industries. So we are at this process. So here the sedimentation is not clearly shown here, but after the grit chamber process, after the grit disposal, so from this going from here to this primary clarifier, here we can see the here you can see the sedimentation process, right? So here you can see the sedimentation. Here you can see the sedimentation process, right? So we have discussed the first unit, the third unit up to primary tank level. So this is a primary tank process, right? So the raw sewage. So the screens, you are having three types of screens: comminator and the grit chamber. In that you are having various types of grit chamber. From here it is going to the primary clarifier, or it is a settling tank. So the main purpose of primary treatment is to remove the scum and the sludge material which is deposited in the water. Next, primary sedimentation tank. So it is also a tank. It is also a tank which is also known as primary clarifier. So if you see where is the primary clarifier located, this is a primary clarifier. So in the primary treatment, the raw water, sewage water is coming from the pipe and it is going into the screens. From here, screen section, it is passing to the comminator section. From this comminator section, again it is passing to the grit chamber section. From this grit chamber, it is going to the primary clarification. So this is the entire primary treatment process where you are seeing, right? Here, the primary sedimentation tank is also known as primary clarifier, and it is located just after the what? Just after the grit chamber. It may be rectangular shape, or it may be a circular shape, or it may be a square shape. So if you see the figure, this one, so this is a circular shape of figure. So in some cases you can see a square box, or in some cases you can see this type of chamber where the raw primary sludge is passing at the other gate and the sewage water is moving into the secondary treatment. So usually at sewage treatment plants, this sedimentation is carried 2 times. So generally in a sedimentation plants, depends upon the size of the plant, the sedimentation takes place in twice. Right? So it takes twice. So one before the biological treatment, another after the biological treatment. So in overall sedimentation treatment plant, so it may be the primary or it may be the secondary. So it generally is taking 2 times. It generally is taking 2 times. So here it may be before biological treatment, other one is a after biological treatment. The sedimentation before the biological treatment is called primary settling, and the sedimentation after biological treatment is called secondary settling. So both the settling is nothing but sedimentation process. But when the sedimentation which is going on before biological treatment is nothing but is called primary settling, and the process which is going after the biological treatment is called secondary settling process. Got it? Right. In this process, the velocity of the flow is decreased to such value that finer settleable will settle at the bottom of the tank. So if you see the figure, the primary clarifier. So here from the grid chamber, the sewage water is going into the primary clarifier. Here the fine disputes of solid particles are settling at the bottom of the tank, right? Settling at the bottom of the tank, and the velocity is very low. Velocity flow is decreased because the settable solids will settle at the bottom of the tank. Such settling tanks in which the sewage continuously keeps on moving with a predetermined velocity are called continuous flow settling tanks. Next one. In the olden days, the sewage was used to fill in large tanks. So what they are using? They are filling the sewage water in a large tanks and allowed it for some time, and then they are emptied. Such tanks are called fill and draw type tanks. So olden days lo manaki setups anni lenappudu different sorts of treatment processes. So they are collecting all the sewage water and dumping in a big tanks and allowing it to for some time. Later it will dry. Right? This type of tanks are nothing but fill and draw type tanks. The liquid sewage coming out of settling tanks, the liquid sewage coming out of settling tanks after the process of sedimentation is called effluent, right? The liquid sewage which is coming from the settling tanks after the process of sedimentation is called the effluent, and this settled viscous sewage at the bottom of the tank is called sewage sludge. So which one is called sewage sludge? So this, so the water is going, this one is nothing but the effluent. See here the primary effluent. So if you get a question in the exam, right, draw a layout of a treatment plant. So immediate vaser and you will get a full marks. That is the primary treatment stage up to here, the secondary treatment stage up to here. So here, whatever the water is going from the primary clarifier or a sedimentation process is nothing but primary effluent. So ఇది మళ్ళీ second stage నుంచి third stage కి వెళ్తున్నప్పుడు we are calling this as a secondary effluent. So whatever the sludge is coming at the bottom and dropping is going other chamber, it is going into the sludge treatment process. It is going into sewage sludge. Are you sure? Next. So the principal construction of a settling tank is shown, which is a basic settling tank, right? So here the sewage water, which is having the solid particles, is coming from the grid chamber and it is going into the inlet, Later we are having various baffle walls coming gates where the scum is settled at the top layer and the sludge is settled at the bottom layer. Then the wastewater, the sanitary water is flowing in this tank and is going to the outlet and it is going to the secondary treatment as a primary effluent. And the balanced sludge based material is coming into the sludge disposal management system. So you can draw the figure of a sedimentation tank in this shape or whatever the separate figure. So if you want to make, you can draw this figure where it is going, where the water is coming, right? Where the water is coming. So here the sludge will be of very finer particles when compared to the before stage. So before grit chamber stage low, the solid particles are somewhat bigger when compared to the solid particles in the sedimentation tank, right? The sedimentation tank or primary clarifier or settling tank. So దీనికి చాలా రకాల నేమ్స్ ఉన్నాయి. First one is we are calling them as a sedimentation tank or primary sedimentation tank or primary clarifier or settling tank, right? Next one. So if you see the real picture of any sedimentation tank, so you can see this one is a grit removal chamber where from the comminutor the screened water is coming into the grit chamber. Here the grit is coming at the bottom and is going out removal tank, and the water which is in the grit, the water which is in the tank is going inside the primary sedimentation tank. So in the primary sedimentation tank, if you see detailedly what you are having various sludge scrapers where it is indented for collection of the scum material, scum, SCUM, scum antunnam. కింద ఉన్న particles we are calling them as a sludge material, right? Next. So here the water is dumping into this chamber, whereby whatever the disposal, whatever the small particles present inside the sewage water is settling at the bottom, and you are having again the scrappers, again the scrapper settlings where the sludge is automatically fed by using the sludge disposable hopper, right? Next, you are having the rollers at the end of this your sedimentation tank. You are having a rollers where you can see the dimensions. The dimensions of the sedimentation tank is 70 meters long into 12 meters wide into 3 meters deep. Okay, na? Next. So these are moved mechanically with the help of a motor which is placed outside the tank. So here the water is passing here in the tank continuously, thereby the sludge is collecting at the bottom, the scum is collecting at the top. Balance water, whatever the water is going from this tank into the as a primary effluent to the clarifiers in the secondary stage, right? Yes. So like this you can draw a figure and you can show detailedly what's happening at this point, what's happening at this. Next. So if you see the specifications, design specifications of the primary sedimentation tank, so if you see the specifications, so here generally the hydraulic specification tank length, their capacity, right? What are the design specifications? You can see here. The hydraulic loading rate, the hydraulic loading rate divided by settling velocity, it may be approximately 0.3 to 0.7 mm per second, and also or it is 1 to 2.5 meter per hour. Next, the overflow rate design, that is 30 to 60 meter cube per day. Next, detention time by retention time TD is equals to 2 hours. Next, the depth of the tank is 1 to 5 meters range. So it may be 2 meters, maybe 3 meters, or it may be 5 meters. That the BOD removal, the biological oxygen demand removal is maximum 20 to minimum 20 to maximum 40%. Next, the suspended solids removal, whatever the solid material is dumped is coming from the wastewater or settling inside the tank, the removal rate is about 30 to 60%. Minimum is 30%, maximum is 60%. Next, the number of tanks can be accommodated depends upon the plant is 2. Next, the sludge accumulated, whatever the sludge accumulating at the bottom of the tank, you are calling them as a sludge. So how much amount of sludge can be accumulated depends upon the water. So 2.5 kg of wet solids, 2.5 kg of wet solids per meter cube of flow. So you are having some sort of specifications based upon the size of the tank. So based upon the size of the tank, these are the design specifications which have some negotiable values. Based upon the values, we can do this process. Next, coming to the types of primary sedimentation tanks. So the basic primary sedimentation tanks are typical primary sedimentation tank, circular radial flow tank, upper flow tanks. So we are having three types of primary sedimentation tanks. That first one is typical primary sedimentation tank. Second one is circular radial flow tank. Third one is upper flow tanks. Right? Okay. Next, problems. So based upon the sedimentation tank design things, so we will discuss about the problems. Next one. Design a primary sedimentation settling tank of rectangular shape for a town having a population of 50,000 with a water capacity of 180 liters per capita per day. So in a locality we are having 50,000 people. So here the water supply is 180 liters per capita per day. Then what you have to do? Then what you have to do? You have to design a primary sedimentation settling tank. Okay. Now, so what is the shape of the tank? The shape of the tank is rectangular in shape. Now assume 80%. Here in the problems, if there is a question given in the exam, assumption is there. Take the assumption in the brackets. If there is no assumption, you have to assume. How you are getting the assume? Problems practice చేసినప్పుడు you will get some what type of number you have to take. So here assume 80% of water supplied to the city is converted into sewage. So assume 80% of water supplied to the city is converted into sewage. Then 80 by 100, 80% అన్నారు కాబట్టి 80 by 100 into how much population? 50,000 population. So 50,000 into how much amount of liters? 180. Okay. 80 by 100 into 50,000 into 180, that is equals to 7,300 into 103 liters per day. Then assuming what? The detention time is 2 hours. Assuming the detention time is 2 hours, therefore the capacity required is 7,200 divided by per day means 24 into detention time is 2 hours. Okay. So per day is 24 into 2 hours, that is 600 meter cube. Let us assume an overflow rate of 30 meter cube per day per meter cube for average flow. So therefore the surface area is 30 meter cube. So the surface area is 7,200 divided by 30. So that is the area. Therefore, so if you are getting 240 meter cube. Next, what is the effective depth? The effective depth is equals to 600 meters. The effective depth is 600. So what is the capacity? So here the capacity required. So capacity means how much volume means the depth. So now the surface area is 7,200 divided by 30 is 240. Next, the effective depth is 600 divided by what is the surface area? 240. Okay. So the effective depth is 600 divided by 240. You are getting 2.5 meter. Depth is 2.5 meter. Then the breadth into length is equals to 240. The surface area under here, if you take the surface area, that is length into breadth, that is 240. Therefore, what is the length here? The length is equals to 4 times the breadth. The length is 4 times the breadth. Therefore, B into 4B. So B into 4B is equals to 240. B into 4B is 240. Right? Now substitute B is equals to 7.5. B is equals to 7.5 value and L is equals to 30 meters. L is equals to 30 meters. Right? Now provide 4 meters for inlet input and outlet arrangement. Then the total length is 30 plus 4, 34. Provided 1 meter depth for sludge accumulation of 0.5 meter as a freeboard. Therefore, the total depth is equals to 2.5 plus 1, 2.5, 2.5 plus 1 plus 1.5, that is equal to 4 meters. Therefore, the dimension of the tank is, what is the dimension of the tank? 34 meter. Length is equals to, total length is 34 meter into breadth that equals to 7.5 meter. The breadth is 7.5 5 meter and the depth is 4 meter. What we have done, right? The depth is 4 meters. So like this you have to design. Design means simply the length, width and height. So ఇది చేయాలంటే you have to see some sort of inputs like input, some sort of material gathering. All these things will be at the material application. Right? Yes. So if I repeat the problem again, simply what is the question asked here? Design the primary sedimentation settling tank of rectangular shape or not. So the rectangular shape means the length, width and depth. The length, width and depth. So depth anamata, right? The depth of the tank. So what is the population? 50,000. What is the water supply? 180. So assuming 80%. So if you take 90% or 60%, so it depends on the question. Question no insufficient data is there, you have to take the data, right? So here it is assumed 80% of water supplied to the city is converted to sewage. Therefore, 80 by 100 into 50,000 into 180 into 180, that is equal to 7,200 to 103 liters per day. Liters per day. Assuming the detention time is for 2 hours, therefore the capacity required is equals to 7,200 divided by per day kabatti 24 into 2 detention time, that is 600 meter cube. So the capacity is 600 meter cube ani telchindi manaki. Then what you have to find? We have to find the overflow rate is 30 meter cube for the average flow. Therefore the surface area is 7,000 divided by 30, that is equal to 240 meter cube. Then what you are finding? Depth you are finding. Therefore effective depth is equals to, what is the effective depth here? 600 divided by 240, right or wrong? So the effective depth is 600. Why? Because capacity is 600. So capacity divided by surface area, that is equals to 2.5 meters, that is equals to 2.5 meters effective depth. Therefore generally area B into L is equals to 240. Then what is the L here? Length is 4 times the breadth. L is equals to 4 times the breadth. Therefore B into 4B is equals to 240. Therefore B into 4B is equals to 240. Therefore B is equals to 240 divided by 7, that is 7.5 meter. So ఈ 7.5 meter వచ్చిన తర్వాత, then 7.5 meter వచ్చిన తర్వాత ఇక్కడ B place లో substitute చేస్తే you are getting the length is 30 meters. The length is 30 meters. Therefore provide 4 meters for inlet and outlet arrangements. So as per the government, so provide 4 meters for inlet and 4 meters for outlet arrangements. Therefore the total length is 30 plus 4, 34 meters. Now provide 1 meter depth for sludge accumulation and 0.5 meter as a freeboard. Therefore the total depth total depth, the total depth is 2.5. The total depth is 2.5. Already depth together. Then what is the total depth? The total depth is equal to provided 1 meter depth sludge ki 1 meter depth ivvali and also accumulation of 0.5 meters freeboard. So pine accumulation. Therefore 2.5 plus 1 plus 0.5. Therefore total depth is equals to 4 meters. So then what is the finally the dimensions of water tank will be? So ఎలా ఉంటుంది water dimensions of a water tank? So by seeing the figure, by seeing the process where you are add, I think everything. So we can see the dimension of the tank is length. Length is 34, breadth is 7.5, length breadth height is equals to 4 meters. So these three are in the design specifications. Therefore the design is safe. Right? Next we'll see the next question. Design a circular primary settling tank. Design Yes, yeah. Design a circular primary sedimentation tank. So here, what is the tank shape? Here the tank shape is circular. Mundu dantlo the tank shape is rectangular. Design a circular primary settling tank for a town having a population of 50,000 with a water supply of 180 liters per capacity per day. So same problem, same values, but only the design. So ముందు మనకి rectangular shape లో problem ఉంది, ఇప్పుడు మనకి circular shape లో problem ఉంది. Okay, right? Now see the given data and assumption data. So what is the sewage flow? The sewage flow is 7,000 meter cube per day. So ఇందాక మనం ముందు చెప్పుకున్నట్టు it is 7,000 meter cube per day. Then what is the capacity required? 7,200 into detention time into 2 divided by 24, that is 600 meter cube as usual. Next, let us provide an overflow rate of 30 meter cube per day per meter cube. Therefore, the surface area is 7,200 divided by 30, that is equals to 240 meter cube. 240 meter cube. What is the next one? Diameter of the tank. So if you see the diameter of the tank, the diameter of tank is 240 divided by 4, that is equal to 7.5 meter. Then the effective depth of tank is equals to capacity by surface area. What is the capacity here? The capacity is 600 meters divided by surface area 240, that is equal to 2.5 meters. Therefore, providing 1 meter extra for the sludge and 0.5 meter for the freeboard. So if you get a question like this, ఈ ఎక్స్ట్రా అనేది ఎంత స్లడ్జ్ 1 meters మీరు తీసుకోవాలి, ఎందుకంటే you have done some problems and the accumulation of depth is 0.5. Then you are, after doing this, you are getting the solution. Design a circular primary tank, right? Next topic is composition of wastewater. So wastewater low, what is the composition generally we are having? So if you get a question, what is the composition of wastewater in a wastewater treatment plant? So you have to write this information. So the typical composition of wastewater is based on strength. Together, the typical wastewater composition is based on what? Is based upon the strength of the water. Now, the important characteristics measured in the wastewater. The important characteristics measured in the wastewater include. So, what are the characteristics to be measured in the wastewater? So, as already we discussed, the first one is the biological oxygen demand or biochemical oxygen demand, BOD, biochemical oxygen demand. So, it should be 100 to 300 mg per liters as oxygen. Oxygen రూపంలో 100 నుంచి 300 mg per liter లాగా ఉండాలి. Next, what is the second one? Suspended solids. Second one is suspended solids. So the suspended solids means nothing but SS. So what is the quantity? 100 to 350 mg per liter. 100 to 350 mg per liter. Next, second one is settable solids. Next, typical composition is settable solids, that is 5 to 20 ml per liter. Third one is total gel nitrogen, that is TKN. We are abbreviated as TKN. How much amount of hydrogen? So here we give the rating of 20 to 80% mg per liter. Next, total amount of phosphorus content. That is 5 to 20% mg per L of as phosphorus. So like this, the composition of sewage wastewater is having the biochemical oxygen demand water, suspended material, settable solids, total nitrogen material, and total phosphorus material. So if you come across any question, what is the composition of the wastewater, you can write these topics clearly, right? Yes. Next one, how the wastewater is treated. So generally you know that how the wastewater is treated, right? So here the wastewater is treated in two groups. Here the wastewater is treated in two groups. First one is gravity method, other one is a microbial transformation. So here the first one is gravity settling of solids. That is nothing but primary treatment అని చెప్తున్నాం. So what we have discussed, the wastewater is treated in two ways. The wastewater is treated in a two ways. Here the first method is a gravity settling of solids. That is nothing but primary treatment. Next one is microbial transformation of organics and ammonia to reduce biochemical oxygen demand. This is simply nothing but secondary treatment, right? First one is a gravity settling of solids, primary treatment. Second one is microbial transformation of organics and ammonia to reduce a BOD, which is called secondary treatment process. The advanced stage on that is advanced sludge removal process. So that is not basically purely involving in the wastewater treatment. A sludge అనేటప్పుడు వచ్చేసరికి అది that is completely solid waste అన్నమాట. So that's why, so we will discuss, we are showing majorly primary treatment and secondary treatment only for wastewater, right? A typical treatment a typical treatment system in a wastewater treatment plant involves, what is the first one here? A typical treatment water involves, first one is a bar racks. So what we have earlier discussed, the bar racks is what is the main intention of bar racks here? The main intention of bar racks is to remove the large debris. So large big debris, solid debris ni ఒకేసారి తీయడానికి this bar racks అనేది we are using. How this bar racks are operated అనేది ముందు మనం classes we have already discussed in detail, right? Second one, primary treatment. So the primary treatment, what is the second point here? Where type 2 sedimentation for flocculated particles are removed. That is, it ranges from 25 to 60 meters, and the detention time ranges from 1 hour to 2.5 hours. And what is the third point? Secondary treatment involves the microorganisms to remove BOD. So what does it do, secondary treatment process? It involves the use of microorganisms to remove from BOD of any solids that pass primary treatment. So primary treatment lo ఏదైతే వాటర్ అన్ని సాలిడ్ పార్టికల్స్ ని సపరేట్ చేసుకొని ప్రైమరీ ఎఫ్లూయెంట్ లాగా సెకండరీ ట్రీట్మెంట్కి వస్తుందో, there we have to remove the microorganisms by using BOD analysis. ఎప్పుడైతే ప్రైమరీ ట్రీట్మెంట్ పాస్ అయ్యి వచ్చిందో వాటర్, then it involves the use of microorganisms to remove the BOD process. Next, the oxygen is limited and must be supplied. So during this various stages of moving of wastewater, మనకి ఆక్సిజన్ సప్లై అనేది చాలా తక్కువ ఉంటుంది whenever it is passing in different stages. That's why we have to provide the oxygen to this treatment process. The most common secondary treatment process is activated sludge. So మనకి secondary treatment plant లో the major process, most commonly used process is nothing but activated sludge form. Okay na? Like secondary sedimentation. So in the secondary sedimentation, to remove the microorganisms from the secondary treatment, so disinfection to kill the pathogens using chlorinated water, H4Cl. So in the secondary sedimentation, these are used to remove the microorganisms from the secondary treatment. So what is the main thing here? To kill the pathogens by using chlorine liquid. So these are the typical treatment train in the wastewater plant involves. So if you get a question, draw the layout of this so on so on. So you can draw the figure of this one. You can draw the figure. So you can draw this figure and you can write the process. You can draw this figure and you can write the process what you are having, right? Next. What is the time? So coming to the treatment stages, the same thing what we have discussed earlier, right? How the wastewater is treated. So in the sewage, so generally we'll discussing about the liquid matter. So the liquid waste from toilets, bathrooms, showers, kitchens, your gardens that are disposed via sewers, trucking, or on the site treatment systems. So that is nothing but sewage. So sewage in we are collecting so via sewers where it is government laid under the ground or by trucking. So ఎక్కడైతే ఇలాంటి ఫెసిలిటీ లేనప్పుడు ఇంటి ముందు ట్రక్ వస్తుంది ట్రక్ లోపల we are dumping or on site treatment systems. So like this the sewage is collected at various points either in the industries or in the domestic or in the storm water. Next, if you see the industrial wastewater, the wastewater coming from the industries of mines generally involves some of the site processing. Some of the site processing. Then, what are the treatment stages? As all we know that is the primary treatment where mechanical treatment is reduced. Mechanical treatment is done to reduce the coarse particles, coarse solids, sand, dirt, oils, and grease. Ideal as pre-treatment or for treating surface water, that is the street water. Involves a screening process, sedimentation process, and skimming process. సో మనకి షార్ట్ ఫామ్స్ లో మనం ఇప్పుడు చెప్పుకున్న స్లైడ్స్ అన్ని షార్ట్ ఫామ్స్ లో you can easily understand the concepts, right? So it involves what? Screening process, as already discussed, 3 types. Sedimentation process, we discussed design and sedimentation, and also skimming process, we have discussed the skimming process also, right? Next, secondary treatment process. So in the secondary design process, treatments designed to degrade biological content of sewage, that is human waste ni food waste ni, it is designed to degrade this content through aerobic biological process. So manaki secondary process lo, so generally we will go with biological content, right? Removal of the microorganisms. So here the biological content of sewage, that is nothing but human waste, human food, etc., through various aerobic biological treatment process that is done in the secondary step. Next, the require aeration for bacterial and protozoan activities to degrade the organism compounds. So what is the secondary treatment is also considering? So it is making removal of the bacteria, requires aeration for bacterial and protozoan activities to degrade the organic compounds. Next point, effluent water and sludge are the byproducts. So secondary treatment plant lo, what are the byproducts ante em cheptunam? The byproducts are secondary treatment process and effluent water and the sludge are the byproducts in the secondary treatment process. So the effluent water, primary effluent water, and the sludge which is settling at the sedimentation tank, ఇవి వచ్చేసి byproducts అన్నమాట ఇప్పుడు secondary process జరుగుతున్నప్పుడు, right? Next, third one is advanced or tertiary. So advanced stages to treatment to raise the effluent quality to the standard required before it is discharged to the receiving environment. ఈ థర్డ్ స్టేజ్ లో ఏం చెప్తున్నాము? అడ్వాన్స్ స్టేజ్ అని చెప్తున్నాం, లేదంటే టెరిషియరీ స్టేజ్ అని చెప్తున్నాం. సో వాట్ హ్యాపెన్స్ హియర్? వాట్ ఎవర్ ద సెకండరీ ఎఫ్లూయెంట్ coming from the secondary stage, here this effluent is raised to the quality standards before it is discharged into the environment. That is done in this tertiary stage. Then what are the potential steps to be taken? The potential steps are filtration, polishing, ponding, nutrient removal, and disinfection. So these are the things to be taken while doing the process. Okay. Next. Okay. So with this, the time is completed. So we'll discuss the topic in the next session. So we'll stop here, and after the completion of this video, I will upload this video in my YouTube channel. From there, the link is forwarded to your group so that other members, those who are not in the class, please share this link to other students, those who are not coming regularly. Just open it, view it, and like it, right? Okay.